Welcome to a new webinar titled How to Be a Prompt Engineer. You know, that's that new role that is supposedly going to replace all consultants, all developers, all managers. In the future, we're just going to be prompt engineers talking to LLMs and they're going to solve all of our problems. I don't really believe that, but I do believe that in this AI era, we have to understand how to work with AI models in a good way. Now, I always like to start my presentation by explaining a little bit where the idea for it came from. And for this one, the prompt engineer one, it came roughly a year ago when internally at Companial we had this sort of innovation day, a hackathon of sorts. And I had this idea that we would build a backlog management helper. Because here's how my day usually looks like. I work with a lot of different partners and I get requirements from a lot of different partners in many different forms. Sometimes it's a Word document, sometimes it's a PDF document, sometimes it's just directly pasted into an email. But at the end of the day, I need to move all of those requirements into Azure DevOps, where we actually do our project management and task tracking. So I had this idea, what if instead of me trying to copy paste everything to Azure DevOps, I could throw these requirement documents into an AI model, and an AI model would extract those user stories for me, and I could then just directly insert them into Azure DevOps. So during that innovation day, in about 10 hours, this is what we came up with. You would log into Azure DevOps, and you would have a big upload button there where you would upload your requirements document and it would get uploaded to Azure Blob Storage. At the same time, an Azure function would be triggered, which would take the requirement document out of the storage, create a prompt with it, send it to OpenAI. OpenAI would extract the requirements, the user stories, into a JSON format, and we could then use that JSON format to call the APIs of Azure DevOps. So that was the idea. And here's how the result looked like after about 10 hours. We knew how to upload the document, how to download the document, how to send an API request to OpenAI, how to get the response back, how to send the API request to Azure DevOps, but we struggled with the prompt. Our prompt was bad. It didn't work the way we wanted it to work. And because our prompt was bad, it didn't matter that we knew how to build everything around AI. Because we didn't know how to work with AI, at the end of the day, the backlog management helper didn't work. This is how our prompt looked like after 10 hours. 3 very poor sentences. And at that point, I knew that if we want to move forward with AI technology, we need to learn how to write good prompts for AI. Now, before we go further into the topic of how do you write good prompts, I just want to make a quick introduction of myself. My name is Tine Staric. I'm an architect here at Companial. I became an MVP roughly 1 year ago, so 2024 was a good year for me. But I'd prefer to introduce myself as being really passionate about 3 things. Right now, I love baking things. I don't know what it is with baking, but that's just the hobby that I love right now. I like brewing beer. I used to have my own beer brewery, and I hope that's a hobby that I pick up again once I'm, I don't know, going back to Slovenia. And I also really enjoy working with Business Central. So those are the 3 things that I am. But on the other hand, what am I not? I am not an AI specialist that has spent the last 10 years working with AI, and I do not have a machine learning background. But I don't think either are you. And that's exactly how I wanted to structure this presentation. This is not a presentation for somebody who has spent the last 10 years working with AI. This is a presentation for somebody who knows how to work with Business Central, but now on top of that needs to learn how to work with AI as well. In terms of the agenda for today, we're going to go through 3 parts. First, I'll try to teach you how do you build a good prompt with structure and examples. And once you know how to build a good prompt, we'll try to make that good prompt great by leveraging some of the model capabilities or some of the framework features that we now have in Business Central. And once we have a great prompt, we're going to talk about keeping a great prompt great. Because I'm already a huge fan of automated testing, the traditional kind of testing that we've known for years. But when it comes to AI features, it's even more important that we test them and that we test them regularly. And I'll show you 3 very concrete reasons why. But above all else, the one thing I want you to take away from this presentation is don't build your prompts the way you talk to ChatGPT. Because ChatGPT is a very powerful chatbot, but the features that we build in Business Central are not like ChatGPT. Okay, before we jump into talking about what makes a good prompt good, I want to show you a demo that I've seen about 2 years ago from a VP at Microsoft, Scott Hanselman, which illustrated for me in a very good way that language models are not some super smart machines that understand our prompts, that understand our questions, but are actually just dumb computers that make predictions and then choose whichever word sounds the best to us. Okay, we've landed into a small little tool that I've built for myself called Token Probability Visualizer. You can just think of this as a ChatGPT, but we are now looking under the hood. Here, I can ask a model to complete a sentence for me. Something like, today is a good day. Let's go to A. Okay, so if this was a live session, I would ask you, where would you like to go? And maybe you would like to go to the forest. Maybe you would like to go to a restaurant. Maybe you would like to go to a party. Maybe you'd just like to go home. Now, let's see how the model would like to complete this sentence. Okay, the model thinks that if today's a good day, we should go to a good place to relax. But let me show you that if I hover over this word, good, that's just one of the words that the model could choose from when it was standing at this point. The safest choice, the most probable word, would be to go to a park. But there's more, there's new, there's party, there's nice, there's cafe. So you can see that model doesn't really understand that it's a good day. Model just knows that park makes the most sense to complete the word from here. And you can see that some of the words here are green, some are yellowish, and some are red. What does that mean? If the word is green, it means that the word had the highest probability. It was the safest choice that the model could go for. While a red word is not the safest word. It's somewhere lower on the list of probabilities. Now, how does the model decide if it should go for a risky word or a safe word? That's all based on temperature over here. Right now, I have my temperature set to 1, which means I'm saying to the model, you can be creative, but maybe not too creative. Pick some risky words, pick some safe words. Let me show you what happens if I remove this completion and switch the temperature all the way down to 0. Let's try to do this again. Okay, now the model would like to go for park because park is the safest option. And you can see that most of the words are now green or yellowish, and even the ones that are closer to red are still the safest options, the most probable words available at that point. So temperature is how we regulate how much freedom the model should have. But there's another way how we can regulate which words the model is even choosing from. So temperature is going to define which words to choose from, risky or safe. But by changing our prompt, by changing the text that we send to the language model, we can have an impact on which words are even being chosen from. Let me show you that if I change the prompt a little bit by saying, I just bought a new swimsuit and today's still a good day. We generate a completion. This time, the model says, let's pick the word pool. And now words like pool, beach, water, swimming, these words have higher probabilities than words like park. So prompting is a way how we influence which words are more probable and which words are less probable. And now, just for the fun of it, let me show you what happens if we give the model all the freedom in this world. Temperature 2, be as creative as you want to be. Let's generate completion. And let's try to make some sense out of this. Today's a good day. Let's go to a free evening game. Okay. But then quickly it starts spitting nonsense. Baby doll, khaki gloss, rap, Julio, horsemar, pot trend, dump, rejoice. It doesn't make sense anymore. But we cannot really blame the model for this garbage that it put in front of us. We told the model, choose all the risky words you want. You can see that all of the words that I hover over have 0% probability. It's not the model's fault. We set the temperature to 2. Okay, but this is all just to illustrate to you that models don't understand our prompts. They make predictions, but with a good prompt, we influence those predictions. So now let's start talking about how do you make a good prompt. This was our prompt after 10 hours. 3 poor sentences. You're a tool that extracts backlog items. If there are any quotes, change them to single quotes, and everything should be in the JSON format in the end. Now, this is not a good prompt. And I feel like the model felt something like this when it got our prompt. Because we left so many details out, it didn't know if it should go left or it should go right. It made all of its own choices when things were unpredictable. And when we wanted the model to go left and it went right, we didn't like it. And if the model went left, but we wanted to go right, we also didn't like that. So that's when we started looking into how do you make a good prompt. Now, how do you make it? You follow these 5 components. I'm going to be repeating these 5 components quite a couple of times today. For a good prompt, it should have instructions, steps, format requirements, examples, and notes. In this first part, I'll share with you a couple of prompting techniques that you've likely already heard of, and that they basically just tie into these 5 components. The first one being few-shot learning, a very common prompting technique. In other words, I would name few-shot learning as don't only tell the model what you want, show the model how you want it. Let's look at this through an example. Let's say we're trying to build a feature in Business Central where a user can come in and give this input. Add 50 units of item A and 100 units of item B to the purchase order. You know, something similar to the sales line copilot, which we already have, but for the purchase side. A naive system prompt here would be something like this. Please extract the items mentioned and return them in JSON format. That would be telling the model what we want. But few-shot learning is saying don't only tell, also show what you want. So by applying the few-shot learning prompting technique, we would also add some examples to the system prompt. So if input looks something like this, please add 30 units of item X, 10 units of item Y, 5 units of item Z. This is how the JSON should look like. And if input something like include 15 units of part A and 25 units of part B, this is how the JSON should look like. And few-shot learning is nothing but examples in our 5 components. So these are the examples that we added to our backlog management helper. An example of how a user story would look like and how the JSON should look like, how a bug list would look like, and how the JSON should look like, and the same for the use case document. So few-shot learning is actually just examples. The next one is chain of thought. Another very common technique, I like to call it give the model time to think. Let's look at this one through a different example. Let's say the user would come in and they would be able to request something like this. Determine if a discount of 12% can be approved for an order value of 8,000. A naive system prompt here would look something like this. Determine if a requested discount can be approved, and here's the matrix. If the value is above 10K, max discount 15%. If it's between 5 and 10K, max discount 10%. If it's below 5K, max discount 5%. Now, if we just gave this matrix to the model, it might work. You know, you send the prompt to the model and you might get a successful result back. And you try it again and you might be successful again. And you try it again for the third time and you might be successful again for the third time. But when you scale your prompts to hundreds or thousands of prompts, that's when you would start to notice that actually they only work roughly 60% of the time. But we would not like to be in the 60%. We would like to be in the 70s, 80s, 90s, 100% of the time. And that's why we apply all of these prompting techniques, because we would like to improve the accuracy. We would like to improve the reliability of responses. And chain of thought, giving the model time to think, it means we don't only send the matrix to the model, we also give the model steps of how it should think through the problem. And think, you know, in air quotes, because we saw a moment ago that the model doesn't actually think. It just predicts the next word. But still, here are the steps that it should follow. Identify the order value, determine the discount threshold, compare the discount with the threshold, and only then make a decision. And chain of thought, in our 5 components, steps. So read and understand the input, identify key components, and structure information. So we know few-shot learning, we know chain of thought, and I have just one more for you, which is prompt reinforcement or anchoring. You know, the more you get into this prompt engineering topic, the more you realize that talking to language models is very similar to talking to more junior developers. If I give a 70-page requirements document to a junior developer, they might be successful in delivering that task, or they might not be. But if I give them some examples of how we've solved those problems in the past, if I give them steps how they should think through the problem, they will be more successful. And the same applies with the language models. In prompt reinforcement, we're reminding the model what we want. So instead of just saying, here's the matrix, here are the steps, at the very end, we are going to add a section with notes. What's the most important part here? Ensure that the requested discount is compared, follow each rule carefully, and only then approve or reject. And the same would apply to our junior colleague, right? We give them examples, we give them steps. But if on top of that, we also share with them, hey, just listen, these are the most important parts that you should look at, well, their chances of success are going to go up. So how do you build a good prompt? Instructions, steps, performance requirements, examples, notes. This was our poor prompt with our 3 sentences at the very beginning. Once we applied these best practices to them, this is how our system prompt actually looked like. Now, this is too small for you to read the text. We're going to go through individual steps in a moment, but I just wanted to show you that a large system prompt is nothing to be afraid of. It's better to have a bigger system prompt that gives us reliable results compared to a small system prompt that gives us unreliable results. So let's go through those 5 components of our backlog management helper prompt step by step. First, we've got instructions. And in reality, anybody who tries to build a prompt does not struggle with instructions. We all know that if we want something from AI, we need to tell the model what do we want. So extract the information from requirement documents, analyze the input, structure the extracted data into JSON. So instructions, usually we don't struggle with that. But the other 4 is where we sometimes forget to include them. Steps, we already saw. Chain of thought, right? We have 3 steps. Read and understand the input, identify key components, structure information. But there's another prompting hint on the slide visible here. Notice how I made some of the words black and bold, and some of the words are gray and kind of fade into the background. I did that to guide your attention into what are the important parts and what's only there for context. And I'm doing the same thing for the model. First, notice that all 3 steps are numbered because it's much easier to understand what step number 1, step number 2, and step number 3 compared to just having a big paragraph of text. And on top of that, you can notice that the first part has these words between asterisks. That's because I want to tell the model this is the important part and the rest is here for context. Okay, format requirements. This is where you would explain if you want to get a JSON back, how should that JSON look like? That it should have a title, that it should have a description, acceptance criteria, priority, dependencies. Examples, we've seen that, few-shot learning, an example of how an input would look like, an example of how an output would look like. And finally, when you're done, add a section for notes where you reiterate what are the most important parts. Always replace double quotes. The goal is to create a JSON output and handle varying document structures flexibly. So how do you make a good prompt? Instructions, steps, format requirements, examples, notes. Instructions, steps, format requirements, examples, notes. Now, as much as I would like you to remember these 5 components, you actually don't have to, because there's now a shortcut. And let me show you that shortcut. You can get to that shortcut by using OpenAI's Playground. This is more like taking a look at ChatGPT under the hood. There's more parameters that you can set up. This is where you would set up your system message, and this is where you could then simulate user messages. Now, in this system message part is where you would start building out your system prompt with the 5 components like we talked about. But notice that there's also a generate button here, which if I click it, it says, what would you like the model to do? And now I'm gonna copy paste my prompt here, not because this is the only prompt that works, but when I try to type long sentences out on webinars, I tend to make a lot of typos. So parse out user stories or bugs from a requirements document and return it in JSON format so it can be used to send API requests to Azure DevOps APIs. Okay, I've still made a typo, but let's create the system prompt here. Let's give it some time. If it's gonna take too long, I do have a backup tab here, but maybe this time it's gonna be sooner. Ah, there we go. So extract user stories and bugs from requirements document. Instructions, check. Steps, identify user stories and bugs, parse relevant information, create JSON structure, validate the JSON. So steps, check. Output format, how the JSON should look like. So format requirements, check. Examples, an example of a JSON, an example of another JSON. So examples, check. And finally, notes. What are the most important parts? Ensure each JSON object uses correct and consistent field naming, consider edge cases, and validate the uniqueness of ID for each JSON object. So this is not going to be like the perfect system prompt that you just take and it works, but it does give you a very, very good head start. If we had this shortcut available to us 1 year ago, trust me, we would not have those 3 poor sentences at the end of 10-hour period. Okay, so either use the 5 components or use the shortcut and you will create a good prompt. And once you have a good prompt, you can turn that good prompt great by realizing that models come with some model capabilities, and also frameworks have some good features, especially in the BCAI toolkit. The first one is JSON mode. Before JSON mode was added to BCAI toolkit, this is how we needed to ask from the model to give us a JSON response. We would say extract user stories or bugs or use cases and return the information in JSON. Please make sure the information is in JSON. No comments, only JSON. Pretty please. And this is what the model gave back to us. Sure thing, here's a JSON with all the information without any comments. Ugh. Yeah, well, this didn't happen as often, but it did happen sometimes. And not only did we sometimes get comments before we got our JSON, sometimes we got only JSON, but that JSON had maybe a bracket too many or a bracket too few. And after JSON mode was introduced, which in the AI toolkit is just one parameter that you set to true, this signals to the model that it can only return the response in JSON and that it has to be a valid JSON. So no longer a bracket too many, no longer a bracket too few. Okay, next, we're going to talk a little bit about tool calling. But at this point, I do have to apologize to you because I really hate talking about AI features through a chatbot example. Because how many chatbots do we need within Business Central? Microsoft is going to build one, Copilot Chat, but that's about it. We don't need 6 additional chatbots within Business Central. However, tool calling as a concept is easier to explain through a chatbot example. So I'm sorry, but here's how I would build a chatbot in Business Central. Let's imagine that we give the chatbot a system prompt where we say, you are a friendly assistant that helps users navigate around Business Central. And the user comes in with the question, okay, hey, what's the status of the order 1001? Now, the model could give 2 responses. It could either say, hey, I'm sorry, but I cannot show you that information because I was not trained on your orders. I don't have access to your orders. I just don't know. Or the model could give out fake information. It could say, your order shipped to Asia. Because like we saw at the beginning, maybe Asia is just a high probability word when you try to generate an answer like this. Neither of these 2 options are a good response for the user. Either they don't get the information or they get wrong information. And here's where tool calling comes in. With tool calling, you can create a system prompt like this. You're a friendly assistant, yes, but you also have access to the following actions. Get order info for details about orders. And when the user comes in with the same question, what's the status of the order 1001? The model can first say to itself, oh, I don't know anything about orders, but I can call this function to get more information, get order info. And then on the Business Central side, we would need to have a procedure like this. This is not a valid procedure. This is just pseudocode, but just to show you how things could look like. A procedure that takes in an order number, it will find the appropriate sales header, and then return some information back to the model, like who's the customer, what's the address, what's the status of that order. And once the model has this additional context, this additional information, then it can generate the final response, which would be something like the order 1001 for 8 Corporation. Well, actually, it's waiting for an approval from Tine. So why is tool calling so important for prompt engineers? Well, because before tool calling, all we could do, well, not all, but main use cases that we were able to go for are either extracting data out of text or generating text for something like emails. But with tool calling, we can now get data from the system or modify data in the system, so we can move away from these two very simplified cases. And I have another example of tool calling that's a tiny bit less chatbotty. Let's say we built a feature on the customer list where the customer can come in and say something like, I'd like to update the credit limits and payment terms for customers in North America because they were good customers this year. So a system prompt would be something like, you're an assistant for managing customer data. You have access to the following actions: update credit limit and update payment terms. So when the user would come in with a prompt like this, the model would first say to itself, okay, I need to call update credit limit with these parameters, and then I'll also call the update payment terms with these parameters. Now, I wouldn't blame you if you're a bit hesitant looking at this example, because if I have to create a procedure on the Business Central to update credit limits or to update payment terms, then how is this any different than me adding an action to a customer list that the user goes there, clicks the action, it opens up a page, the user enters which dimension they would like to use and what's the new value, and then that same procedure would be executed to update all of the credit limits or payment terms. It's exactly the same. It's no different. But I want you to keep the next words in front of your eyes when you think about this AI period. AI is nothing but an interface to what computers could already do for decades. For decades, we knew how to update credit limits, and for decades, we knew how to update payment terms. However, for decades, the user had to go to the customer list and then figure out, where is that action? And when they find the action, what are the inputs that I have to put in these fields? Now they can also just type out the request in natural language into a box, and then the model will know exactly what to update and what to execute. But still, AI is nothing but an interface. As a side note, Andrew Burko here is a very good influencer on AI topics, in my opinion, because he's much more reserved. He's not screaming all the time that AI is going to take our jobs, AI is going to replace us. He takes a more scientific approach of seeing where will AI help and where it won't. So it's good to see a perspective that's not so marketing driven, because sometimes it's just overwhelming hearing all the news about AI. Okay, so you know how to make a good prompt, and now you've learned of two ways how you can make a good prompt great, either using JSON mode or by adopting tools. But what's the point of a great prompt if the users don't know how to use them in a great way? That's where prompt guides come in. Because if you put this kind of text box in front of a user where it says, describe the number series you want to create or change, the user will describe them in 100 different ways. Half of them might work, half of them won't work. So instead of just putting a blank screen in front of the user, you should create prompt guides. You know how your feature works best. And if you know how your feature works best, you can create these placeholders for prompts that the user can select from. If your feature works best for creating new number series or for modifying new number series, give some examples. Because once the user selects it, it will paste that placeholder text into the box, and they can then further modify it or add additional information. And that's gonna make both the user happier and you, because otherwise you are gonna be frustrated that the users don't know how to use my AI feature, and the users are gonna be frustrated because, well, they just don't know how to use your AI feature. So prompt guides, a brilliant feature of the BCAI toolkit that I highly recommend you use. Okay, so we talked about building a good prompt and taking a good prompt into a great prompt and teaching the users how to use a great prompt in a great way. And then the last piece here is, how do you keep a great prompt great? It's all about testing prompts. Now, I did say at the beginning that I'm a big enthusiast for automated testing, but it's even more important for AI features. And here's three very concrete examples why AI features are so much different. If you're a developer, you know of the concept called pull requests and code review, right? A process where somebody else is going to look over your code and see if everything works or if there was a mistake. And for example, if I would write some code to delete all customers when somebody clicks post, well, somebody would flag that during the code review and say, no, we're not merging that code in. But things become harder when you talk about AI features. What if somebody removes a line from the system prompt? Does that make the feature better or does it make the feature worse? If you don't have tests, you cannot really tell. So reason number one why you should always test your AI features is because your developers can break them and you won't know otherwise. But it's not only about developers. OpenAI can break your features. Right now, OpenAI is again putting out many different new models. We got O3 Mini a couple of weeks ago, and then GPT 4.5 was released. But the most commonly used one is still GPT 4o. But in reality, it's not GPT 4o. It's GPT 4o from August. And before that, it was GPT 4o from May. Before that, it was GPT 4, GPT 40613, GPT 40314. All of these models are different and they behave differently. So if you don't have any tests for your AI features, how do you know that when the next model comes around, do your features work better or do they not even work at all anymore? So the second reason why you need to test your AI features is because OpenAI can break them. And then there's also the third actor that can break your prompts, which you might not really think of, and it's Microsoft. Here's how. You now already know what's a user prompt. It's the question that the user types in. What's the status of the order 2234? And you know what's a system prompt. It's what we've been talking about. So extract the order ID, use the get order status tool. That would be an example of a system prompt. However, every time you send a prompt through the BCAI toolkit, before your prompt actually reaches the large language model, another prompt gets added on top of it. It's called meta prompt. Now, meta prompts are there to prevent, let's say, disturbing responses from being shown to the user. Some meta prompts would include things like ensure that no sensitive or confidential information is disclosed, avoid speculative or unverified details. So meta prompts in themselves are a good thing. We don't want to show to the user some disturbing information, right? However, the problem with meta prompts is that actually we don't know how a meta prompt looks like. And a bigger problem than not knowing what a meta prompt is that we don't know when a meta prompt changes. And when a meta prompt changes, that's a new block of text that's reaching the LLM, and that can break your features. And if you're not testing your features, you're not really aware of that. So the third reason why you should absolutely test your AI features is because meta prompts can break them. Okay, so we know that testing is important. Then let's talk about how do you actually test an AI feature. Let's go back to our example with the determining if a requested discount can be approved or not. So how would I test a feature like this? I would come up with a set of different questions to the model. Something like determine if a discount of 12% can be approved for an order value of 8,000. And I would specify that the expected result is reject. And then I would come with multiple examples here. 7%, 6,000, approve. 17%, 20,000, reject. 3,000, 8% reject. 20,000, 20%, 25,000, reject. And I wouldn't only change the numbers, I would also change the wording. Determine if a discount. Can I give discount? Is a discount for order value? Is discount acceptable? So you can use AI to generate even more cases like this. And once you have more test cases, if you want to be a friend to the developers, you should package them all in a JSON file where you specify that one property is question, so what the input should be like, and what's the expected response. And here I'm going to show you just a little bit of AL code because things on the AL side are changing as well. If you have done automated testing before, you know that this is how a test procedure would look like. You might also know that if you wanted to cover 18 test cases in the past, you needed 18 different test procedures. But that's no longer the case with AI testing. With the new AI test toolkit that Microsoft has released, you only have to build one test procedure, and it will be executed for every one of those lines in the JSON file that we saw a moment ago. And here's roughly how a test procedure would look like. First, you would write some code that you need to extract a question from that file and the expected response from that JSON file. Next, you would run your AI feature with the question and you would get back an actual response. And then in the final part, you simply assert the two, compare if the expected response is equal to an actual response. And why I really wanted to show you this piece of code here is because testing AI features is not going to be as developer heavy as traditional testing is, because you need one test procedure, but then all of those cases, they can be written by prompt engineers, they can be written by consultants, they can be written by anyone, and the tests are going to be executed through this one test procedure. Okay, so now we're coming to the end, so let's just quickly wrap up. How do you build a good prompt? Instructions, steps, format requirements, examples, notes. Follow these 5 components or get a head start by generating a system prompt on the OpenAI's playground. How do you take a good prompt and turn it great? Use features that the models have. Use JSON mode, use tool calling, and to ensure that users are going to use your great prompts in a great way, give them some prompt guides. And once you have great prompts, how do you keep them great? Well, test, test, test. Because your developers can break them, OpenAI can break them, and meta prompts can break your features. And with that, we come to the last part, where I'm going to say thank you for watching this webinar. If you've got any questions or you're interested in this topic, feel free to reach out to me either on Twitter, on Blue Sky, on LinkedIn, wherever you want. But just before I wrap up, I want to say one more thing, which is don't build your prompts the way you talk to ChatGPT. Don't build your prompts the way you talk to ChatGPT. Thank you. That's all.